In this section, we are going to look at systems of inequalities. We're going to graph a linear inequality in two variables. Then we're going to look at a mathematical model involving linear inequalities. And then we're going to graph a system of inequalities. Linear inequalities in two variables and their solutions. Equations in the form ax plus by equals c are straight lines when graphed. If we change the symbol equals to greater than, less than, greater than or equal to, or less than or equal to, we obtain a linear inequality in two variables. A solution of an inequality in two variables, x and y, is an ordered pair of real numbers with the following property. When the x-coordinate is substituted for x and the y-coordinate is substituted for y in the inequality, we obtain a true statement. Each ordered pair is said to satisfy the inequality. The graph of a linear inequality in two variables. The graph of an inequality in two variables is the set of all points whose coordinates satisfy the inequality, and there may be an infinite number of them. What's the procedure for graphing linear inequalities? 1. Replace the inequality symbol with an equal sign and graph the corresponding linear equation. You can graph it either using intercepts or perhaps slope-intercept. Draw a solid line if the original inequality contains a less than or equal to or a greater than or equal to symbol. So draw the line solid if you have less than or equal to or greater than or equal to. Draw a dashed line if the original inequality contains a less than or a greater than symbol. So draw the line dashed if you have less than or greater than in your original inequality. 2. Choose a test point from one of the half planes. So when you graph this line, there is a half plane above the line and a half plane below the line. Or if it's a vertical or horizontal line, to the left or to the right of a vertical line, or above or below a horizontal line. So you're going to choose a test point in one of these half planes. Do not choose a point on the line. Substitute the coordinates of the test point into the inequality. If the statement you obtain is true, shade the half plane containing the test point. If a false statement results, shade the half plane not containing this test point. Let's demonstrate. Having sharing issues. All right, here's our example. Let's graph this linear inequality. We have 4x minus 2y is greater than or equal to 8. Now you can graph the line one of two ways. You can graph it using the intercepts, which is what I'm going to do, or you could solve this equation, because we're going to replace the inequality with the equals. You could solve the equation for y and use the slope and the y-intercept. Let me demonstrate those two methods. All right, first we need to graph the line. So I am going to graph 4x minus 2y equals 8. And when I graph this in my coordinate plane, I'm going to graph this as a solid line. And it's going to be solid because we have greater than or equal to. And if I have greater than or equal to or less than or equal to, I'm going to draw my line as a solid line. All right, so I'm going to find the x-intercept. And to find the x-intercept, I set y equal to 0. And when I set y equal to 0, the minus 2y goes away, and I get 4x equals 8, or x is equal to 2. So the x-intercept is the number 2. To find the y-intercept, I set x equal to 0. And when I set x equal to 0, the x term goes away. Minus 2y equals 8. Divide by -2, and I get y is -4. So I'm going to plot those 2 points on the coordinate plane and draw a solid line. Now I could have solved for y and used the slope of the intercept. I just think this is way more difficult than using intercepts. But in some cases, it may be necessary that you do it this way. So I have 4x minus 2y equals 8. I'm going to subtract 4x from both sides. And then divide everything by -2. And I get y is 2x minus 4. So I see that the y-intercept is the same value that I got from finding the y-intercept by setting x equal to 0. And the slope of this line is 2. So I can graph this either way. All right, so let's graph this on the coordinate plane. I have an x-intercept of 2 and a y-intercept of -4. So I'm going to plot those 2 points. And since my original inequality was a greater than or equal to, I'm going to draw this as a solid line. So in MyMathLab, you pick the line tool, you graph your line, and you're going to have it as a solid line. You're not going to pick the dashed line. If this were greater than, not greater than or equal to, we'd graph it as a dashed line. All right, so now, since I'm graphing an inequality, the solution of this inequality is going to be either the half plane above the line or the half plane below the line. So I need to determine which it is. So I'm going to pick a test point. And you can pick any test point that you want as long as it's not on the line. Okay, so the easiest one to test, if I look at this, is 0, 0. Now, I could certainly pick another point besides 0, 0, but that just seems to be the easiest one for me to test. So I'm going to plug that into my inequality. That is a false statement. 0 is not greater than or equal to 8. So this is false. So I'm not going to shade the half plane that contains that point. I'm going to shade the half plane that does not contain that point. So I'm going to shade below the line. In MyMathLab, you have a bucket tool. So you would choose the bucket tool and then select the area that you want to shade, in this case below the line. And you're going to use your bucket tool to shade that area, that half plane in the coordinate plane. All right, what if you have something like this? Y is greater than or equal to 2. When you have a line, y equals a constant, that is a horizontal line. So we're going to draw this line at y equals 2. So I would pick 2 points on the horizontal line, y equals 2, any 2 points there, and I'd graph the line. And I'm going to graph it solid because I have greater than or equal to. All right, there's my horizontal line at y equals 2. Now, am I going to shade above or below this line? Well, since its y is greater than 2, we would shade above. You could also pick a test point to show that that's true. Let's pick 0, 0. Now, this inequality does not contain x, so we don't have to substitute x, but we would substitute y, and that is false. Since that's a false statement, we do not shade the region that contains that point. We shade the other region. All right, how about this one? X is less than 2. When we have x equals a constant, that is a vertical line. And we're going to graph this vertical line at x equals 2. Now we're going to graph this as a dashed line because we have less than, not less than or equal to. So since we have just less than, we're going to graph this as a dashed line. Now, do I shade to the left or do I shade to the right? Well, since it's less than, we're going to shade to the left. Less than would be to the left of this line. Now, you could pick a test point. Again, pick 0, 0. And 0 works. That is a true statement. So since it's true, we're going to shade the half plane that contains the test point. So we would shade to the left of our dashed line. All right, an application that shows how we might use a system of linear inequalities. The latest guidelines, which apply to both men and women, give healthy weight ranges rather than specific weights for your height. If X represents the height in inches and Y represents weight in pounds, the healthy weight region can be modeled by the following system of linear equations. So there is a system of linear equations. We have linear inequalities. We have 2 inequalities, and there is a region of ordered pairs that satisfies both of these inequalities. If we were to graph these, we could see that they do intersect, and there are regions that are created by these 2 lines in the coordinate plane. So show that the point 66, 130, or a height of 66 inches and a weight of 130 satisfies these guidelines. And the way you do that is you substitute and show that it satisfies both inequalities. So we'd substitute 66 for X and 130 in for Y. And we would substitute 66 in for X and 130 in for Y. And we would show that both of those statements are true, and they are. So you get, for the first one, 193.4, and that is greater than 165. And for the second one, you get 114.2, and that is less than 125. So someone who's 66 inches tall and weighs 130 pounds, excuse me, is within the recommended guidelines. So this represents a system of linear inequations where there is part of the graph in between, above, around, we'll show you how to do that, that satisfies both inequalities. All right. So the solution set of a system of linear inequalities in two variables is the set of all ordered pairs that satisfy each inequality in the system. Thus, to graph a system of inequalities in two variables, begin by graphing each individual inequality in the same rectangular coordinate plane. So you're going to graph all your lines in the same coordinate plane. Then find the region, if there is one, that's common to every graph in the system. This region of intersection gives a picture of the system solution set. So the way we do this is we graph our lines, then we're going to pick a test point. Now, when I have two lines, I'm going to get 4 regions, and I'll show you how that works when we graph these. And I'm going to pick a test point in one of the regions. If it works, I shade that region. If it doesn't, I pick another point. If it works, I shade that region. And I just keep going until I find the region that satisfies the system of inequalities. Now, if it were me, I would graph this system of linear inequalities using intercepts. It just looks so easy to me to find the X and Y intercepts of these two lines. So that's what I'm going to do. So I'm going to first graph this equation, and I would graph it as a dashed line because it's less than. All right, to find the x-intercept, set y equal to 0, so x is 6. To find the y-intercept, set x equal to 0, negative 3y equals 6, so y equals negative 2. Now we're going to do the second one, and I would graph this as a solid line because it does have greater than or equal to. To find the x-intercept, we set y equal to 0. We get negative 3. To find the y-intercept, we set x equal to 0. And we get y as negative 2. So I'm going to graph those intercepts on my coordinate plane. Okay, so we have 6, 0, and 0, negative 2. And we're going to graph that as a dashed line. All right, and then we're going to graph negative 3, 0, and 0, negative 2. And we're going to graph that as a solid line. All right, now I need to shade one of the 4 regions that have been formed by the intersection of these two lines. Region 1 would be above the two lines. Region 2 would be over here, where it's below the solid line, but above the dashed line. Region 3 would be where it's below both lines. And region 4 would be where it's below the dashed line, but above the solid line. So I need to decide which of these 4 regions is a solution to my system of linear inequalities. And to do that, I can just pick a test point and see if it satisfies my system of equations. And the easiest test point in this case to pick is 0, 0. And if it works, I'm going to shade the region that contains that point. If it doesn't, then I need to pick a different point. So if it doesn't satisfy this, then I pick a point in region 2. If that doesn't satisfy it, pick a point in region 3. If none of those satisfy, then it will be region 4. You can eliminate the first 3 regions and say, yes, I'm going to shade 4. Okay, so what was my original inequality again? My system of inequalities? We had 3x minus 3y is less than 6, and 2x plus 3y is greater than or equal to negative 6. And if I replace x and y with 0 in the first inequality, that will be true. But I have to check the second one. So if I replace x with 0 and y with 0 in the second one, I get 0 is greater than or equal to negative 6. That is true. So I would take my bucket tool and I would shade the region that contains 0, 0. And that concludes section 5.5.